Hello again. This is Math 2231 coming to you from the College of DuPage. And the title of this lecture is The Solution to the LSA, Limit Problem Including Epsilon, Deltas, and such. As always, please be an attentive listener while watching this video. For completeness, let's start with the statement of the LSA. So you want to figure out what is the limit as h goes to 0 of the cube root of 1 plus h minus 1 all over h. And in part B, what I want you to do is use that. You see, we need to know the limit before we can do an epsilon delta proof. So prove that your answer to part A is correct and use this and prove this using a complete epsilon and delta argument. Notes suggesting some numerical data and some inequalities that might be useful in doing this with the squeeze theorem. Okay, so let's proceed with the solution then. The empirical data that I shared with you leads to the inductive conjecture, which I encourage you to embrace without proof. That's a smiley face. Such that for h small enough, you can conclude that the cube root of 1 plus h is bigger than or equal to this expression and less than or equal to 1 plus h over 3. So in this case, then, what I can do is subtract 1 everywhere. When I subtract 1 everywhere, this one goes away and this one goes away, and I subtract 1 there. And so I have that, but then I can divide all the way through by h because we have a factor of h here and a factor, more than a factor of h here. So when I divide both sides by h, which in this case is a positive number, at least let's assume it is positive, it's negative, the inequality, it's still this expression, the cube root of 1 plus h minus 1 over h would still be caught in between these two expressions. And so by the squeeze theorem then, as h goes to 0, this becomes 1/3, this becomes 1/3, so we know that this limit does in fact exist, and it must equal 1/3. So that limit as h goes to 0 of the cube root of 1 plus h minus 1 all over h does exist and is equal to 1/3. Now we needed this limit in order to do the epsilon delta proof. So note our limit of this, and this is a little bit of an aside, but it is another way you could have gotten at the limit without using the squeeze theorem. You see this limit, the limit as h goes to 0 of the cube root of 1 plus h minus 1 over h is also the derivative of this function, the cube root of x evaluated when x equals 1. Think about that, but that is true. Thus, this limit is in fact the derivative of x to the 1/3, which is 1/3 x to the minus 2/3 evaluated at x equal 1. And you plug in the number and you get 1/3. And as I conclude here, there are often many paths to an answer in math. And both of these are useful for you to consider. Okay, so now we need to proceed with the epsilon delta proof, though, once we figured out what L was. So let epsilon greater than 0 be given. We need to find a delta greater than 0 such that when the absolute value of h minus 0 is less than delta, implies that this difference, this is our expression minus L, is less than epsilon. Well, recall we had previously demonstrated that difference quotient is between minus h over 9 and when I subtract 1/3, so this is between minus h over 9 and 0. Now, if you think about that for a while, and you could have h being positive or negative going there, but that forces you to conclude that the absolute value of this expression that's in between the cube root of 1 plus h minus 1 over h minus 1/3 is less than, and you see what I'm going to get is it is less or equal to the absolute value of 1 over 9 times the absolute value of h, which is the same thing as 1 over 9 times h minus 0. So if epsilon is greater than 0 is given, and we take delta to be 9 epsilon, if h minus 0 is less than 9 epsilon, then this expression is less than 1 over 9 times 9 epsilon, which is epsilon. And so we've shown if epsilon is greater than 0, we can take delta to be 9 epsilon, and then we conclude that this limit is less than epsilon. And that concludes the proof. You may want to think about that for a while, but this is a full epsilon delta proof. In closing, now more than ever, time is precious. Each day must count. Do the math, it will make you strong. And now more than ever, take care of yourself, because self-care is important, and take care of each other because we're all in this together. Strive to make a difference each and every day. Look forward to seeing you in class, and God bless you all.